In this video, we're going to check if this function here is differentiable at x equals 1. So to do that, we need to take the limit from the left and the right as we approach x equals 1. So let's do that here. Take the limit approaching it from the left, which is the top part of the piecewise function. So that is equal to 1. Let's now take the limit from the right, so the bottom part of the piecewise function, which will be x squared, and see if the limit is the same. 1 squared is 1, so this function is continuous at x equals 1. We now need to check if the function is differentiable at x equals 1. Just because it is continuous doesn't mean it is differentiable. So we have to use the definition of the derivative, which is that limit. So let's substitute our function into the definition. So approaching h from the right, the left, sorry, we're looking at x equals 1, a location, so let's replace that. So we now have h, 1 plus h, or 1 plus h, take 1. The 1 and the negative 1 will cancel out, so we're left with the limit h over h, which simplifies to 1. So the value of this limit will be equal to 1. Let's now use this definition of the derivative to calculate as h approaches 0 from the right. So exactly the same definition, but we're now going to use x squared, the bottom part of the piecewise function, because that is on the right hand side. So x plus h squared, take away x squared, take away that function. Now I'm going to expand the x plus h squared term. Firstly, substitute for our x location, which is 1. So expanding this term out in the brackets, then we can do some cancellations. So the h will cancel out on the top and bottom there, and we're left with 2 plus h. We can then substitute the 0 in for the h, take the limit, and our limit is equal to 2. So this value, taking the limit from the right, is not the same as this value here from the left. So this means it's not differentiable, this function, but it is continuous at x equals 1. So if we take a look at the graph, we can see why it is not differentiable. It's because of that sharp point there at x equals 1. We can see it is continuous, but because of that sharp point there between the left and right piecewise functions, it is not differentiable at that location x equals 1.